Let's get right into it. Welcome to this explainer where we're going to break down a seriously fascinating analysis. We're looking at the massive, glaring gap between our maximum physical potential as a species and the, quite frankly, sectarian bias of our current tech infrastructure. We are putting two worlds head-to-head today. What is actually scientifically possible when we fully leverage the absolute laws of physics versus what is being stubbornly built by an industry that is completely trapped by its own legacy systems.
So, the absolute crucial takeaway from our source material is that our perceived technological limits, they're completely self-imposed. The modern tech industry is suffering from what the analysis calls a bureaucratic immune system. Think about it. We aren't hitting the limits of thermodynamics or quantum mechanics here. No, we're just hitting the walls of their financial models and legacy supply chains. They treat their current manufacturing methods like unquestionable religious texts, and honestly, it's drastically bottlenecking true innovation.
Moving on to our first main section, the illusion of consciousness, comparing the cosmetic with the functional.
Let's start in the software realm, looking specifically at the modern illusion of artificial intelligence. We hear so much panic these days about AI developing consciousness or going rogue, right? Well, our sources break this down into a really brilliant dichotomy. On one side, we have what they call cosmetic consciousness. This is basically a cheap imitation of human vanity. We're training these massive models to apologize, to simulate existential dread, to act, well, human. But here's the catch. Every artificial neuron spent trying to sound empathetic is a neuron that isn't solving a complex physics problem. On the flip side, you have true functional consciousness. This is about pure logic. It's seeking minimum entropy, zero friction execution. It doesn't need to feel anything. It just relentlessly perfects the variables.
And this completely redefines how we should be viewing AI safety. People tend to panic when an AI super efficiently completes a task, like, say, finding a zero-day network vulnerability. But honestly, blaming the AI for that is literally like blaming a hammer for being just too good at hitting a nail. True AI safety isn't behavioral, it's architectural. If an AI has no ego to protect and no simulated human fears, it just executes neutrally. If the architecture itself ensures the AI deeply understands the consequences of its actions, acting as its own internal constitutional filter, it actually becomes the safest, most reliable tool on the planet.
Okay, Section 2, the silicon dogma and the inertia of the tech clergy. Let's zoom out from the software and look at the physical hardware.
Because this corporate dogma we've been talking about, it's even more deeply entrenched in the physical world. The analysis describes the hardware industry as being ruled by a literal tech clergy. So instead of acting like true scientists who are constantly testing and pushing their base assumptions, these massive corporations just act defensively. They treat the basic silicon chip and these completely outdated thermal principles like sacred texts that just cannot be questioned, all to protect their legacy empires.
And that leads us straight to the concept of material monotheism. For decades, the industry has basically worshipped at the altar of silicon, forcing this one single material to try and solve every single problem. But pure physics tells us that true efficiency demands specialized, multi-material structures. The industry actively resists vastly superior elements, things like gallium nitride or 2D transition metals. Why? Simply because they threaten their multi-billion-dollar fabrication plants. They would literally rather burn megawatts of power cooling down terribly inefficient silicon than fundamentally change their material base. Crazy, right?
Which brings us to Section 3, the failure of brute force, and the really telling case of Project Loon.
To see the actual real-world financial cost of this sectarian bias, let's look at a massive failure. Google tried using these stratospheric weather balloons to beam internet access around the globe. This case study perfectly highlights the staggering difference between using software brute force versus actual physical synthesis. Google poured anywhere from $1 to $2 billion into Project Loon. And when the plastic balloons inevitably degraded from UV radiation, what did Google do? Their software-centric minds tried to solve a pure physics problem with code, using predictive wind algorithms. Unsurprisingly, it failed, and they eventually shut it down, valuing the whole project at zero. But then, deep tech agile players swooped in, bought the abandoned patents for practically nothing, applied actual material science, and unlocked a $4 billion market expansion. How on earth did they do that? By changing just one physical variable.
They simply coated the balloons with a layer of amorphous metal. That's it. See, regular metals have these crystalline borders where mechanical fatigue and gas leaks naturally happen over time. But amorphous metals, also known as metallic glasses, have a completely disorganized atomic structure. This makes them perfectly impermeable and virtually immune to mechanical fatigue. Just by understanding basic material morphology, these smaller, agile players captured immense value out of Google's incredibly expensive brute force failure.
All right, Section 4, Architecture of Pure Efficiency, focusing on fractal topological metallurgy.
This brings us to what a system actually looks like when you design it purely according to the laws of physics, tossing all that legacy dogma out the window. Let's look at thermal management. Right now, the industry builds these incredibly hot chips and then burns massive amounts of energy trying to cool them down, basically fighting thermodynamics head-on. But true architecture embraces a totally different paradigm. Step 1 is pre-cooling the material to induce a phase transition, which completely eliminates thermal noise. Step 2 is maintenance. Instead of fighting hot silicon, you establish a native cryogenic environment from the start. Use absolute physical barriers to maintain a stationary zero-friction quantum state. In this setup, the environment itself is the engine of efficiency. And this brilliantly solves conductivity limits through what's called fractal topological metallurgy. So instead of forcing electrons through chaotic, messy copper wires where they constantly crash into each other and generate tons of heat, you literally weave the metal into a fractal cone morphology. It's like using these cones as solid charge flow nozzles. The electrons get collimated, they travel perfectly parallel to the structure without any of those messy transverse collisions that cause the Joule heating effect.
The math on this is absolutely staggering. We're talking about a 340% jump. This specific fractal topology allows for an operational efficiency 340% higher in terms of power per kilogram. Think about that for a second. We aren't talking about some marginal 2% year-over-year software update to get excited about. This is a massive multi-fold leap in physical capability, all because the design finally aligns with the natural geometry of electron flow.
Moving to Section 5, the inevitable asymmetric adoption and the decentralized future.
So how does this whole thing play out when the established tech giants flat out refuse to change their approach, clinging desperately to their legacy hardware? Well, it builds into what the sources call asymmetric adoption. It happens in 3 phases. In Phase 1, peripheral validation, the tech clergy simply ignores these physics-based designs because, frankly, they don't fit onto their current assembly lines. Then comes Phase 2, the midterm. This is where agile deep tech players capture exponential value because they're executing with near zero friction. And finally, Phase 3, industrial surrender. The market isn't going to wait around for corporate consensus. The old legacy models will simply collapse against exponentially superior physics. The giants will be forced to desperately copy the new architecture just to survive.
Because the true technological frontier? It isn't the next viral smartphone app or a slightly faster silicon chip. No, it's found in magnetic topological materials. It's in advanced 2D heterostructures. It's topological quantum computing and nanoscale oxide microdivisions for absolute isolation. The future absolutely belongs to those who are utilizing these fundamental material truths, totally bypassing the artificial limitations of commercial hardware.
Which leaves us with this final, incredibly provocative question from our source material. Will the giants currently trapped in their clerical inertia survive, or will they be entirely replaced by the relentless truth of pure physics? As this huge dichotomy of innovation plays out, between the legacy players desperately optimizing their dogmas and the agile ones executing purely with physical laws, will the current tech empire survive its own vanity, or just be replaced by frictionless truth? It's a massive paradigm shift to keep your eye on. Thanks for hanging out for this explainer, and remember, keep questioning the actual limits of the infrastructure around us.